transformations. All of these transformations in the middle here are exactly the same as everything we've done so far, okay? Changes to the table, exactly the same as what we've done so far. A and K affect the Y table. B and H affect the X table, and they do it by doing the opposite, okay? The X values we're going to use, I'm going to use the same ones from here from the parent. So go ahead and fill those in. Starting with -3, -2, -1, 0, 1, 2, 3. My functions, the quadratic function, the parent, is y equals x squared right here. If I plug in -3, -3 squared is 9. -2 squared is 4. -1 squared is 1, 0, 1, 4, and 9. Let's go ahead and graph those points. -3, 9. -2, 4. -1, 1. 0, 0. 1, 1. 2, 4. 3, 9. Okay, remember the absolute value had straight sides, but the quadratic is a parabola and the sides are curved. Make sure you draw your parabola showing that curve, okay? All the way even at the bottom, it's rounded. All right, so a few little reminders. We know the vertex is the point where the graph changes directions. This is my vertex. It's right here in the center. Okay, so the vertex is 0, 0. Hopefully you kind of remember from geometry, geometry and Algebra 1. The axis of symmetry is the line that goes straight down through the vertex, dividing the parabola into the right side and its mirror image on the left side. Okay, that is the equation of the line. It crosses the x-axis at 0, x equals 0. Okay, so I'm circling my vertex. My roots are when the y is 0. Okay, roots are when it crosses the x-axis, crosses or touches, and when the y is 0. This only has one root. That'll be the root right here. That root is 0, 0. There's only one of them. Okay. Looking at this graph, domain is all real. Range is from 0 included through infinity. Okay, so this is my parent equation, my parent table, my parent graph. Okay. All right, so looking at the first transformation, okay, the words first. X plus 3, inside with the x, it does the opposite. So it's going to go left 3. Outside, it does the same. It's going to go down 4. Inside affects the x-axis by doing the opposite, subtract 3. Outside does the y-axis, exactly what I see, so minus 4. Okay, fill in the table. Subtract 3 from every x. -3, -5, -4, -3, -2, -1, and 0. So -6, -5, -4, -3, -2, -1, 0. Those are my x values. Y values subtract 4. So get 5, 0, -3, -4, and then back up. -3, 0, 5. Again, your vertex, this is where it changed direction. It's going down, 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 and then it starts going up, up, up. It's that center of symmetry. Go ahead and graph it. -6, 5, -5, 0, -4, -3, -3, -4, -2, -3, -1, 0, 0, 5. Vertex, I have it circled. It's that point where it changes direction. -3, -4. Axis of symmetry goes through the vertex and divides the parabola into two reflective pieces. Okay, two symmetrical pieces. This crosses the x-axis at -3. Okay. Roots, that's where it crosses the x-axis. That's where the y value is 0. I can see it on the graph. I can see it in the table. So we've got -5, 0, and we've got -1, 0. Domain, looking at the graph, is all real. Range begins down here at -4 included up through infinity. Okay. All right, let's look at number 2. Again, inside does the opposite direction than I think, so this will be going right 5. This negative is outside, so when it flips or reflects, it's going to flip it going up and down, which will be over the x. Inside affects the x table by doing the opposite. So I'm going to add 5. Outside affects the y column by doing exactly what you expect. It's going to multiply by a negative. So x column, I'm going to have 2, 3, 4, 5, 6, 7, 8. Y column, every value is going to switch sign. I can see that change in direction with the symmetry right there in the middle. Circle your vertex. Go ahead and graph it. 2, -9. 3, -4. 4, -1. 5, 0. 6, -1. 7, -4. 8, -9. All right, so I see that reflection. I see that it moved right 5. Vertex, 5, 0. Axis of symmetry, let's go ahead and draw it. Goes through the vertex and divides the parabola in half. That crosses the x-axis at 5. X equals 5. Roots, on the graph where it crosses or touches the x-axis. On the table where the y value is 0. So my roots, I've got 5, 0, and that's all. Nothing else. Domain, all real. Range, I still have a lot of people getting the range wrong when it flips. This range does not, going from bottom up, smallest to biggest, it does not begin here, it ends here. So my range comes up from -infinity, stops when the y value is 0, including 0. Okay? Make a special note of that because I'm still having a lot of people making that mistake. All right, let's look at the back. Okay. All right. So again, inside does the opposite, so that's going to go left 7. Outside does the same, and it does everything vertically. So outside is a vertical stretch. This will be a vertical stretch. Okay. All right. Looking at the table, inside affects the x, and it does the opposite, so -7. Outside affects the y, and it does the same, so it's going to multiply by 2. All right, so we've got -10, -9, -8, -7, -6, -5, -4. My y values, everyone's going to multiply by 2. We've got 18, 8, 2, 0, 2, 8, 18. This is my vertex. Okay. Remember what I said the other day? If your graph loses just 1 point on either end, so I'm losing these 2 points if I use this grid, it's okay. I'm all right with that. but no more than that. So I'm just not going to graph this one or this one. Okay, I'm going to go ahead and leave the grid the way it is. If it was going to lose more than 1 point on each end, I would have to renumber my graph. All right, so we've got -9, +8, -8, 2, -7, 0, -6, 2, -5, 8. Okay, we can see it moved left 7, and it's vertically stretching, skinnier. Okay. All right, so my vertex, I have it circled. It's this point right here. -7, 0. Axis of symmetry goes through the vertex, cutting it in half, goes through the x-axis at -7. X equals -7. Roots, I can see on the graph there's only one. That's where the y value is 0. Those are my roots. Roots, zeros, x-intercepts, they're all the same thing. So my only root is -7, 0. My domain is all real, and my range begins here where the y value is 0. Oops, sorry, including 0, and goes through infinity. All right, the last two, what's different about them? Take a look, make sure you notice. These are those ones, last test, I say we went from less than 20% getting it to more than 50% getting it. So I'm hoping we'll hit 100% soon. Okay, this has a b value that has to be factored out. Both of them do. Before I can do anything else with this problem, I have to rewrite it. Notice the squared still goes up here. I'm going to get rid of one of those. All right. Everything that was inside the parentheses is still inside the squared value. So we'll pull out the negative, and we've got x plus 3. And at the end, we have plus 9. Okay. It's really important to remember that the b values inside the parentheses being squared, after you factor it, it still has to be inside being squared. Okay? All right. So let's look at our transformations. Now we're looking here. We're not looking here. Boom. So inside here, this is going to do the opposite. It's going to go left 3. The negative's going to flip, but because it's inside, it's going to flip horizontally, which means it's going to flip over the y. And then this is going to go up 9. Okay? All right. X. First, I multiply or divide, and then I add or subtract. So I'm going to be doing two things to the x, and I have to do them in the correct order. So first I have to multiply or divide. So I'm going to divide by -1. That's the negative. And then I'm going to subtract 3. I'm going to put this over here so we can see it better. Divide by -1 and then subtract 3. The y value, all I'm going to do is add 9. Okay, so let's look down our x. First, we're going to switch the sign, and then we're going to subtract 3. So positive 3 minus 3 is 0. Positive 2 minus 3 is -1. Positive 1 minus 3 is -2. 0 minus 3. -1 minus 3 is -4. -2 minus 3 is -5. -3 minus 3 is -6. Okay. All we're going to do to our y column is add 9. 9 and 9 is 18. 4 and 9 is 13. 10, 9, 10, 13, 18. Here's my vertex right there where it changes direction. All right. If we use this 10 by 10 grid, we're going to lose 2 at each end. That's not acceptable. We're going to have to change what we're going to do. Let's go ahead and change everything to just be by 2. 2's. So that means 2, 4, 6, 8, this will be 10. 2, 4, 6, 8, this will be 20. Okay, this will be negative 10. This will be negative 20. Okay. Our x values were really fine. I think I'm just going to leave them alone. Okay. All right. Recognize that will change a little bit how fat or skinny it looks, and if that's going to bother you, then go ahead and change your x grid also. All right, so let's go ahead and graph. 0, 18. Negative 1, 13, 10, 11, 12, 13. It's right there in between 12 and 14. Negative 2, 10. Negative 3, 9. Negative 4, 10. Negative 5, 13. And negative 6, 18. Okay, let's go ahead and make our graph. All right, so flipped over the y, did not change one thing. And then we moved left 3, looks good. Okay, vertex, I have it circled, negative 3, comma 9. Roots. Where does that graph intersect the x-axis? Remember, the roots are where the graph intersects or touches or crosses the x-axis. It does not. So I have got no roots at all. Axis of symmetry goes right through the vertex, dividing the parabola in half. So it crosses the x-axis at negative 3. Domain is all real. Range begins right here at 9, included, and goes through infinity. It's good? All right. Being really careful about that b value. When you see it, you've got to deal with it first. So looking at number 5, again, we've got to write it properly, factoring out the b before we can go on. So y equals, and again, I'm going to keep everything inside the squared and nothing else is going to change. I just need to factor out that 1/2. So we've got 1/2 x. 1/2 times what number would give me a 1? 1/2 times what number would give me a 1? Well, 2. If I check this, 1/2 x, 1/2 of 2 is 1. So check, that still is equivalent. Okay? All right. Remember, what's inside affects the x column by doing the opposite. Multiply and divide before you add or subtract. So this says I'm multiplying by 1/2. To do the opposite, I'm going to multiply by 2. This says plus 2. To do the opposite, I'm going to subtract 2. First multiply or divide, and then subtract 2. This minus 2 over here is going to do exactly what it says to the y. That's a lot of 2's. All right, let's go down the x. Times 2 minus 2. So we've got negative 6 minus 2 is negative 8. Negative 4 minus 2 is negative 6. Negative 2 minus 2 is negative 4. 0 minus 2 is negative 2. 2 minus 2 is negative 1. 4 minus 2 is 2. That's not right. Let's see. 2 times 2 is 4. Minus 2 is 2. All right. I made a mistake right here. Notice it doesn't seem to be following the pattern. 8, 6, 4, 2. This one right here, 1 times 2 is 2. 2 minus 2 is 0. Sorry about that error. Hopefully you did it right. 3 times 2 is 6. Minus 2 is 4. My y column, all I have to do is subtract 2. So we've got 7, 2, negative 1, negative 2, negative 1, 2, and 7. Right in the middle is my vertex. So my vertex is negative 2, negative 2. All right, let's graph it. Negative 8, 7. Negative 6, 2. Negative 4, negative 1. Negative 2, negative 2. 0, negative 1. 2, 2, 4, 7. Oh, I didn't write my transformations. We'll do that next. Hopefully make sure they match what we said was going to happen. All right, let's go ahead and do the transformations up here. Remember, I can't look here. I have to look here. So the 1/2, I know it's going to lower the sides, but what do I call that? When it's inside, I have to refer to it as horizontal, which is a stretch. Horizontal stretch, because that lower number is going to lower the sides. I can see that's what happened. Plus 2 says I'm going to go left 2. And the minus 2 at the very end says I'm going to go down 2. So I'm happy that's exactly what I have there. Axis of symmetry goes through the vertex and divides the graph in half. Crosses the x-axis at negative 2. X equals negative 2. Roots. Where does the graph cross the x-axis? It goes right here and right here. But we don't know exactly what those are, okay? After we do this unit a little further, we'll be able to do the math to come up with those actual numbers. But for right now, I just want you to write between what numbers does the root exist. Okay, here's how I want you to look at it. I want you to see this is above the x-axis, below the x-axis. In order to go from above the x-axis to below, that's right where it passes. In between the x values of negative 6 and negative 4. Okay, that's one of my answers. In between negative 6 and negative 4, it goes from above the x-axis to below the x-axis. That means it crossed over the axis to get from above to below. Then as I keep looking, below, 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 above. Right here in between these two